Okay, so yeah, I'm going to start right now. Good morning, everyone. First of all, I want to start by thanking you all to be here, 9 a.m. in the morning, hearing me talking about indexes, databases. Like, really, I'm not taking this for granted, so yay. And this is the last day of the conference, so well done, all of you, for making it so far. So we're going to start the day with what I hope will be really easy talk. Maybe we'll learn something new. Maybe we'll remind ourselves some old things we already knew before. But I promise you, it will be very fun. So my name is Avishag. All my friends call me Vichy. I'm based in Munich right now, and for the past over a decade, actually, I worked for few companies, and I experienced databases of all kinds, of all types, everything. And after years, I can tell you that I'm confident enough to explain the motivation of this talk. So your actually motivation for this session would be the buzzword, okay? The AI. Wow, AI, mind-blowing. What it does, it has to do with databases, specifically. In this session, we're going to focus on relational databases. Well, the fact is that AI, in many cases, is not going to assist you that well. We hear about context and prompts and everything. Well, I tried and tried and tried many times. I really wanted my Claude, my GPT, my cursor to make success. Helping me and assist me with queries, and the fact is that they doesn't have always the full context. So yeah, even though we are in the middle of this used generation, I'm a very traditional person, and I really believe that we need to have really good foundations in order to succeed and achieve in our field. So this will be your goal. You need to understand that. For the basic stuff, if you don't really know them, your goal for your teams and maybe, I don't know, juniors that you are mentoring, you need to understand that the AI magic is not always here to assist us or not yet, okay? So, yeah, just remember it. So even though I'm going to repeat stuff that you heard before, you might knew before, so it's still going to assist you. And we're going to start with our story. We're going to talk about a subject that is close to my heart, buying clothes online. And let's think about us in NDC. We are trying to build a system, and this system is basically an online store. And this online store, we're going to sell clothes, we're going to manage delivery, we're going to manage transactions. NDC is a retail company in our story, and it's going to sell clothing and ship them worldwide. And what kind of data should we store? So usually you have the schema, right? The big schema, maybe sometimes few schemas. And if you are modeling, and I'm not going to focus about how we are modeling the data, where I'm just going to talk about the concept of the data that we're going to store. Hopefully we will have our transactions stored somewhere, our registered users probably, tracking info, maybe in another database, maybe in the same database, and stock data. So without further ado, we're going to hop on to our demo right away. So we're going to focus on stock table. And I prepared stock table in advance. I have the NDC schema. I'm using MySQL with Docker container because it's easy for me to clear the cache if I need. So this is what we're going to do. And before digging in, I want us to explore the tables together. So we have two tables in our schema. We have stock and we have price. And I hope you can see it. But if not, we're going to query them. So we're going to quickly select, OK? We're going to quickly just select so we can fill the data. We have our stock table. I limited to 10 items just because we don't need all of it right now. We have just the serial ID of the table. We have the item ID, which is given to each item. We have the type of the items. We have the stock number. So it basically represents how many items of this shirt are in stock. And some metadata fields like created it, updated it. If we want to support soft delete, it will be deleted it, so on, so on. And near this table, we have another table for this demo. We have prices. And this is a very small table for demonstration. Basically, it contains the item ID and the price. So each item in our store has its own price. In more advanced systems, we have promotions and so on. But for the simple demo, this is what we're going to work with. And for the first action, I'm going to query a single item. And how does it going to look? So usually, like from the user experience, we'll have our amazing website, and then we'll have a list of items, and we're going to select a single item, so we'll have more details. In this case, this is what the query is going to serve us. We're going just to basically select a single item. Okay? We don't need this limit. We're just going to see this single item. Yay! So item number 103 is a shoe. We have 260 shoes in the stock. Yeah, so this is how we query a single item. And now, let's say I want to query all of my shoes. Sorry. How would it look? This query is very basic. We're just going to filter the shoes, and boom, we have all the shoes. Nothing new so far. So what are we doing here? The question that needs to lead us all the time is, can we make this faster? So of course, when I'm querying directly through my IDE, I get it very fast. But remember that in scale, for big systems, those queries can get some times. Like, I can tell you that almost every system or every company that I worked for experienced issues, even like they wanted to query a single item. So the question, can we make this faster? And this is where indexes are starting to play. So what is the concept of index? And I want you just like to understand the idea of it and less dig into the technical aspect. But basically, for me, an index is a shortcut. It's a data structure that sits in the server of your databases along all the data and basically holds pointers and reference to the actual items. So if when someone like tells you, oh, it doesn't work well, oh, so you just put an index put index on it. What it actually means, create a data structure that sits along this data and holds those pointers, those references to the actual data. And this is like throw you back, at least me all the time, throw me back to data structure, courses from the university when I held my head and I said, what is this? Well, this is it. This is why we use it, and it's actually an amazing stuff. Now, if it's not easy to understand, like, I don't know, who ever had, when you were young, who ever had encyclopedia in his house? Right, okay, so we're all on the same, same generation. So yeah, I remember times when I didn't know a term, and today, like, it makes no sense, right? We just, like, ChatGPT everything. Like, it's even crazier because I wanted to say, like, I had here Google, so it's not even Googling anymore. I just like, if I don't know what bird is, or my daughter doesn't know what bird is, so I just like tell her, oh, so just like ChatGPT it. Like, but for me, it was a nightmare. I had a few encyclopedias. My mom had them in our library, and she told me, what do you mean you don't know it? Just like look up for this in the encyclopedia, and I would actually look it in the book. So it's just like, for me, the index back then really helped me. What is an index in encyclopedia? Just an extra book, an extra data structure that holds reference for the actual position of the term that I'm looking for in the books. So if I didn't know what bird means, I would just simply go to the index book, look for a bird, right, alphabetically, and there I had the position of the specific book in my encyclopedia, the specific page, sometimes the specific row, and here it goes. It's just like a longer process because it had to be manually, but yeah. So this is the concept of index. This is literally what index means. Just an external and extra data structure that I hold in the database. So when you are actually querying a table by a column that has an index on it, instead of going all over the data in the table, it's going to stop right there, go. It knows that it has an index, or look for an existing index over this column. It goes and checks it, and if there is an index, it's actually going to use it to improve. So the optimizer, and we're going to get into the optimizer, what it means later on. So it's going to use the index, and upon the index scan, it will return the rows that matches the index, and that this index actually refers to. So the concept is very easy to understand right now. Those data structures can be very, there are multiple kind of indexes that exist in the world. So the most popular, the most common one which we see for relational database would be the B tree or the B plus tree. This is the most common used index. This is usually what will be the default in most databases. But there are actually much more hash indexes, and we have bitmap indexes, and we can have a long list of it and a full session for each one of them. But just as a concept, this is what index stands for. So the question is, when should we use index? So my answer would be, it depends on what are you going to do in most cases. So you are going to see your system and to work with your product/architects, and you are going to ask them, or you're going to guide your developers, hey, please ask, what are the functions that our system going to serve? What kind of searches and kind of queries we're going to have in most cases? So if you are looking for a specific item, index will be kind of helpful, right? Because it's like the obvious shortcut. I'm going just to use the index and just get this item right away. But if I'm going to basically have to read the whole books, the whole encyclopedia, holding an index, as much as amazing as it is, it doesn't really help me. So you have to keep this on your mind, when should we use the index? So without further ado, let's put an index. So we have those two queries, and we're going to start with creating a basic index on this column. So how it will look. So we are going to create an index, and after that, we're going to name it. So the most common conventions, and there are actually I saw many kind of conventions. So you have a shortcut of index, and then you'll have the column, and afterwards you'll have the table. So if I want to index item ID and stock, it's going to be looking like this. So item ID, stock, right? On which table, stock, which com, item ID. And here you go, you have your index. So we just created an index. Amazing. What happened here? Sorry. We're querying the same data, we get the same data, but is there any difference? So this is the question. And for this one, we're going to move to the output. So what happened here? We can see that with index, the execution took me 8 milliseconds. And without an index, and for this one, we're going to drop index. I just dropped it. Let me just flush the tables. So it will not use any kind of caching. And we're going to do the same, OK? So remember, we had this 8 milliseconds. What will happen now? 62. Now, of course, in terms of milliseconds for us, it's not that bad. But it's like, I don't know, more than 6 times, right? So there is like a huge difference when we are using an index or not. So what actually happened here, we queried this single item from tons of data. And in this case, the index helped us achieve the data faster. And for that, we saw, and we talked, and we, sorry, at this point, I want to talk with you about the optimizer that executes the query for us. So what we saw here, we saw the execution time, right? And I told you about like the optimizer, what it does, it like tries to choose between using an index or not. But what is actually very important to understand, this optimizer, this like magic word called optimizer, is actually one of the most important components the databases have. So what is the optimizer? The optimizer is the component that actually reads your SQL, or for example, it reads your SQL. It actually kind of rewrites it. We're going to see how it does it. And then it decides on a plan, and then it actually executes. And the way the optimizer decides on a plan, the way it does it, it uses basically, imagine like the database, it's like a server. So it collects many statistics in the background, and based on those statistics, it's actually getting getting smarter or whatever. And based on those statistics, it's going to choose our plan, execute, and results. So actually, when you are writing, sorry. So when you are writing select select calls, I hate this, okay, from table, amazing, where blah, 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 the compiler does it in a different way. It actually starts with the from statement, okay? Then it's going to do all the conditions, filters, whatever, and then only after that, this autofill, it's going to do the select. And this is what we call the presentation layer. So when we are writing a query, a lot of you, like a lot of us, start to do the select statement. So okay, what I want to do, I want to have this count, blah, blah, blah. And then we are going to move to the from table, and then we're going to do the condition. But actually, what the optimizer, when the optimizer reads the query, it starts from the source, it starts from the table. It's going to ask itself, where is the data coming from? And what data is going to get there after I'm filtering? And only afterwards, I'm going to do the select. So this is like how the optimizer works. And based on the statistic that the optimizer collects, the server collects all the time, it knows how to provide you with the best plan. Like if this where is going to provide me with a lot of rows or not, this is where the optimizer chooses if it's going to use an index or not. So basically, yeah, this is like 2 words about the optimizer. And the way we are going to understand its plan, and currently we have an index, okay? So we're just going to use explain, analyze. And with me running that, we're going to see a hint of what the optimizer is going to do. So in this case, when I'm filtering, now we don't have the index. Yeah, we dropped it. So without an index, the optimizer is going to have a full scan on stock in order to provide me with this single item. But when I have this index now, you are going to see it like this. It's going to use the index lookup in order to get me the data. So basically, this is like a really cool way to understand how your database is going to execute your queries. And it also gives you like a reference and estimations like how much it's going to take. So if that's so easy, and it's that so like that helps so much, just let's add another index. So before that, we wanted to get all the shoes in our store. So why not create an index on it? So let's create index, again, index type stock on stock type. We assume that if we'll create an index, it will be helpful. But before we're going to create this index, we already know what is the optimizer. So we're going to use it. So optimizer, we're going to ask you kindly what we are going to do. So explain, analyze, select, stock, type, shoes. Is it going to use the index? Obviously, no, because the type com does not have an index. So let's create an index. Amazing. Does it going to use the index? Interesting. OK, it's going to use the index. But let's check. Oops, sorry. Let's check now the performance. Yeah, flash tables. We're going to clear the cache. We're going to drop it before and just like compare it afterwards. Amazing. So we don't have an index. Let's execute the query. Sorry, let's flash the table. Let's execute the query and check what's going on here. So the time that the optimizer spent on executing this query was about 9 milliseconds. Amazing. Let's add an index. Flash the tables. On repeat. OK. And select. So same result, same query, different approach, different way. Actually, now it's, sorry. Yeah. So what we can see here, no improvement, nothing. And even sometimes, I will tell you, it can be even higher. And why does it happen? Like before, it was a reduction like by 6 times. But in this case, it didn't help us at all. In fact, it even like make it worse because now I hold the data structure, another like more memory on my disk. So interesting. We have an index. It's supposed to help us, but actually it doesn't. So this will be that one time that when you are just like randomly adding index, yeah, this query doesn't perform well, yeah, just add index. This time it will not going to work. It's not going to assist. There are other ways, there are workarounds, but the simple index will not work. It actually will make your database slower. So what happened here is that by querying type shoes, we actually got a lot of rows. So it kind of like depends, first of all, on how diverse your data is, the data that you are querying, and how large the data that you are going to get back out of the whole pool is going to be. So actually, in this case, indexes might even slow us down. So why not indexing every column? First of all, as we saw, it's just not always the best practice. It's just not. And second of all, for small tables, it doesn't make sense. Because creating an index by itself, hold it like along the database, it just like doesn't make sense to manage it all the time. And also, you need to remember it actually consumes space on your disks. And also, another disadvantage of using indexes would be the high rate of inserts and updates. So upon every insert that you are inserting, the data structure that we are holding on the side will have to hold a reference to the new row. So instead of just like inserting one row, you'll have like few actions that are going to be done. So you'll have insert row, and then you're going to index, and you're going to insert. It also consumes times. Literally, data structure occurs in the university. So yeah, it's just like, it's something to keep on your mind when you are experiencing bad performance in your databases. Indexes are just not always the best way to go, even though it sounds like a magic. So my real secret for you in this case would be to really understand the query pattern of your system. Before going to explore the data that you have, you just need to understand what are the patterns that you are going to use, like in most cases in our system. And after that, you are going to sit with someone or yourself, and you are going to explore your data. And you are going to understand how does this data look like. So in our case, what happened here, the type. We wanted to filter the type. So a simple query like this would help me to understand how much data I'm going to get back. So select everything from stock, group by, type, and what we are going to do, we're just going to count, okay? We're going to see how many items are in the database grouped, aggregated by the type. And you see, because shoes contains kind of high percentage, not really, but it's not a single row, it's a bunch of rows, this index didn't help me. Now, a better example to see and to understand the performance in this case would be to filter shorts. Why? Because you can see that shorts has a really big amount of rows. So we're going to drop the index, flash the table, run, and
just the S and the N
shorts, of course. It still took me a long time because the data is, yeah, amazing, thank you. So, yeah, shorts. It took the optimizer 7 milliseconds, by 7 milliseconds. And when I create the data, flashing the table, selecting, 9 milliseconds, even higher. So it's basically kind of the same example, but now having this information to see how like kind of they were, like how actually the data is distributed, we can really understand why, and we can really understand what to expect. So if I'm filtering something that returns me really, really like big data, many lines, it doesn't really, I wouldn't say it doesn't make sense to have an index, but in this case, it actually slowed us down. So again, it's not really the magic, a magic tool to index everything, and you have to understand your query patterns in the system, what you're going to expect, and your data. Amazing. And now we're going to play a little game. For this one, we're going to have you all focused and to read the queries that I'm going to write. And together, we're going to guess, will it break or no? So, oops, same slide. So, functions on columns. How would it look like? So for instance, I have the type, and I want to filter it. And because I'm not sure, usually like in our systems, I'm going to remove this one for now. Yeah. So usually in the systems, we are not really executing like hard-coded queries like this, where usually we'll have this filtered from the web app. It's going to search, the user is going to search only for shorts, and it's going to get back to the system, to the databases, and then you'll have the shorts. So in a lot of cases, because backend developers are in one team and the UI developers in another team, we're going to just make sure that the input will be lowercase, but from some reason, someone did this, OK? And remember, we have an index. Yeah, this means we have an index. So my question for you for this game, who thinks is going to use an index? Who think it doesn't going to use an index? Amazing. So yeah, that's right. So when we are applying functions on the com in our condition clause, it's going to have a full scan instead of using the index. So actually, when you see a query like this on a PR review, you are going to right away check, first of all, if the developer aimed to use an index or not. And if no, just write a huge comment, hey, you just like break the index. It doesn't make sense to use it. Amazing. Casting. So for instance, I want to do something like this. So cast item as yeah. So did it work? Yes. But the question is, why we have this index? Did it use the index? Yes or no? Who think it didn't use the index? And who think it did use the index? Well, let's see. Full scan, no index usage. So it's again the same kind of concept. If you apply undue manipulation on the where clause, even though you have an index, it's not going to use the index. So any kind of manipulations on the com that has an index on the where going to provide you with full scan in most cases. Another case, and this is a very interesting one. We have an index on this com, right? We have the type. The fact that it, in this case, doesn't really help us, doesn't matter. We're just going to use this again to understand the concept. But basically, imagine someone search in our web app in our NDC store for anything that starts with SH. So it either will be shoes or shirt or something like this. So this is how I would query it, right? We're going to do the select from stock where type like sh. Amazing. Will it use the index? Any of you think it doesn't going to use the index? Well, let's see. Wait, hold on. It's supposed to use the index, sorry. Nobody did. Yeah. Sorry, filter, like. Well, something is off for me. Sorry for that. But basically, basically what's supposed to happen in this case, when you are using the like one, if you want to find like similarity, it's actually going to use the index, but only in specific cases. And I'm going to tell you what I mean. So let's say I want to do something like this. In this case, when I'm looking for the substring in the query, this one actually, if I use the traditional B-tree index, this one, what I expect is, from it, is not to use the index. And why is that? It's because in the indexing, especially in characters, it's going to use the first letter as a key for my index. So, and afterwards, it's going to use the second one and the third one. So me trying to filter something with this similarity is actually, in a lot of databases, it's not going to use the index unless I'm going to define a specific special index for it, which called a trigram index, which basically what it does, it goes through characters, divide them into groups of 3, and with that, it has pointers for every 3 letters within the word. And this way, the index really can help us. But in most cases, this pattern will actually break the index, while in many databases, probably not in MySQL, sorry, but in other databases like Postgres, like Oracle DB, MS SQL, this one actually use the index. And why is that? It's because I'm only trying to understand what starts with this prefix. And when I'm trying to look up for what started with this prefix, if I'm maintaining the index, it's actually basically, it's kind of like searching like an equal condition. So it will just look for all of the word in my index that starts with this prefix. Therefore, in this case, it will use the index. But yeah, in this one, it did use the index because it's a different database. Another one. Wrapped subqueries. So subqueries. For instance, I have this, the stock table. I want to see, in stock table, we have the stock number, right? I want to see if stock.com, let's see. I want to see all of the items that has more than 200 items in stock. Why? Because, I don't know, the data analyst asked this, because the go-to-market wants to see what they need to put promotion on. So we're going to do something like this. And there we go. We have all the items. Yeah, we have all the items in my stock that has more than 200 items in stock. Amazing. What will happen next? I'm going to wrap this. I'm going to name it as Q. And only afterwards, yeah, I'm going to filter. I hope it will work this time for me, yeah? But yeah. We're going to flash the table, make sure we have the index. Let's see what's going to happen here. So in this case, for the subquery, what happened is it does use the index. Who thought it will not use the index? Well, actually, you are not that wrong, all of you who raised your hand, because for some databases, this pattern actually will break the index. Let's see how. Let's try to break it, you know? So we're going, instead of having a subquery, we're going to use a CT. Now this one, it's kind of, it's very similar to have a subquery, only it's reusable. Okay? It's reusable, it has its own advantage, but this is not why we are here today. So what I'm going to do, I'm going to load the data of stock to this table, and only afterwards I'm going to filter the item. Let's try to break the index. We'll see. So here we go. Here we have, it uses the index, flash the table. Let's see. Again, the index works. But you have to know that for many other databases, this one is actually not going to work. When you are loading it into the memory, into another table, another kind of filtered data, in most of the cases, the optimizer will not know how to use the index, if at all. So 1 second. This one is actually a string. Yeah, it still does use this index, but in many cases, it does not. So this is a case where it does, and it still uses the index. But if you see something like this in a code review, you have to keep in mind this can be very tricky, and it needs to be implemented in a right way in order to use the index. Concatenating expression. So, it's like kind of a funny way to filter. Sometimes I actually use it one time. So we're going to do something like this. Item and I have an index on both of them. I have an index on item, and I have index on type. So 103 and shoes. Will it use the index? No, it doesn't use the index. And why is that? Because, again, I did a manipulation on the where clause. I converted indexed columns into a unified column kind of way, yeah? And then I only did the filters. So in this case, the index is broken. By the way, how can we overcome this? Like, let's say someone does want to query a function like this. They want to make it work. So there is a workaround for it. What we're going to do, if we are actually understanding that this is like a pattern that we are going to meet many times, we're going to have a way to make this work. What we're going to do is instead of holding the index like this, we can manipulate the index into something like this. So what it does, it's going to run this function. It's going to run this function lower on item, not lower, because, yeah, lower on type, not on item. It's going to run this function lower on type. It's going to go over all of its values. It's going to lower them, and then it's going to create the index. So this is what we call an expression index. So for cases when you're not going to have a lot of benefit of the traditional B-tree index, because of these expected queries, we actually have the ability to manipulate our indexes into what we want. So you're going to basically have flexibility to do whatever you like in this matter. So you can have a lower, you can actually concatenate, you can apply casting on indexes, so this would work. The index will hold the values of the return, the values of our function that runs here. This would be the keys, and in this way, this will actually use the index. So before that, we So it doesn't use the index, right? Remember? A full scan. Now we'll create an index. Sorry, item ID. So we'll do lower item ID, another name. And now, index lookup. So there are workarounds to support this kind of queries. Math expressions. So for instance, I want to do this weird query, okay? I want to do something like item ID plus item ID from stock equals to something. In this case, it's going to be like this, right? Will it use the index? Yes or no? Yes? It's going to use the index? No. Amazing. So again, the same concept. Whoop. Full scan, because we have this manipulation. How we can overcome it? By basically indexing the function that we want to use this index for. So it's just really a really cool way to understand how you can improve your queries without like even work that hard. So basically, if we want to sum risky places that the index that we had can really not be used, would be either function on columns, what we saw, casting, which is like almost like function on columns, any substring would be very risky when it comes to index. It can really cost a lot. Wrapped subqueries, wrapped CTEs, concatenating expression, math expression, but luckily we have workarounds and databases that can handle it, even though it's not supported in all of them. So yeah. When it comes to index, and there are advanced optimizations you can use. The example we saw today would be the expression indexes of computed values, this one. We also have partial indexes to be more specific if you are expected for a specific kind of conditions. And basically, my biggest advice to you would be to review your queries in order to see that there is no risk on the indexes there. So what we covered today was our system NDC clothing online store, the index concept. We understood the difference between scan and full scan and index scan, any kind of scanning. We created indexes. We felt how it looks like. And we learned why indexes are actually not always that valuable for us. And the most important thing I want you to take from it is, first of all, index is not the magic tool when it comes to improving your performance, your database performance. And another one, even though you have index, you have to understand how to query in order to use it properly. So yeah, this is like two things I would like keep in my mind the next time I'm going to make a new system or model a database. Thank you all for coming. It was very nice. And if you have any questions, just like feel free to come and to ask. Thank you very much.